Alright, so we already have discussed some parts here that uh, we don't need to reiterate anymore, like your proamnion, then your the areas pellucida, opaca, and the primitive streak. Let's introduce you to additional structures, landmarks that we have to remember, like our notochord. Okay, so in the early development of vertebrata, that notochord serves as a support structure, so provides mechanical support for our embryo. And aside from mechanical support, notochord provides chemical messengers that actually tell the ectoderm to start undergoing the process of neurulation. So it's very evident on this area that the neural folds are beginning or are about to meet. So we know for a fact that chemical messengers that make or that dictated the ectoderm to form the neural folds, the neural plate, and later on form a closed continuous neural tube is actually coming from the notochord. No? Also, let's introduce you to somites. Somites are blocks of mesodermal tissue that are on either sides, okay, or either side of the notochord. So these somites actually form brick-like structures that exist in pairs. At 33 hours, you will be able to appreciate that there are about 12 pairs of these somites. And if I'm not mistaken, the first pair of somite actually appears during the 21st hour, and then every hour from that time, not sure if it's 20 or 21st, but every hour after that time, there will be one pair of somites that will be added. Now, let's see. Alright, so this is another view of the 24-hour chicken embryo. Here we are seeing a structure identified as the anterior intestinal portal. Alright, so the anterior intestinal portal class as identified here as an open structure that actually looks like a cut finger glove. You know? So this one's anterior intestinal portal. Alright, take note that the primitive streak is growing smaller as the incubation period of the growing embryo is actually increasing, or as we uh, take a look at older chicken embryos. Now, if we're going to cut a 26-hour chicken embryo, you'll be able to appreciate now the development of of important structures like the central nervous system. So remember that the process of neurulation already took place. We know that the neural tube is about the neural tube is about to completely close now. So we can expect central nervous system structures like the brain and the spinal cord. Though it would be technically incorrect to say that we already have a full a fully differentiated central nervous system. You cannot really say that you already have a differentiated brain or technically determined spinal cord. So here we cut through the longitudinal uh, side or longitudinal direction. So we cut this longitudinally. We can see this kind of micrograph. So you're seeing on this micrograph a very prominent space on the dorsal side of the animal. So this space here is said to be the cavity of the neural tube. So we call it the neurocele. Some portions of this space will become the brain, and the other portions will become the spinal cord. Right. Now, just below it, you can see the first part of the